Welcome to Scroll to Code. Before we go any further, let me tell you one thing clearly. Whether you are completely new to programming or you already know a little C, this video matters because everything you learn in C will quietly depend on what we understand today. So, stay with me till the end. Not because I say so, but because this is where confusion usually begins. Today, we are not writing programs, we are understanding what happens before a program runs and how it actually executes inside the computer. Once this picture becomes clear, syntax will stop feeling random and logic will start feeling natural. So, let's begin at the very root. Here is the first and most important truth. Computers do not understand C language. Not because C is bad and difficult, but because computers never designed to understand human friendly languages. This one idea explains why beginners often feel lost. If computers don't understand C, then what do they understand? A computer understands only machine instructions. These are very small steps, very exact steps executed in strict order. Every action, printing output, checking conditions, looping, happens only through these instructions. So, when you write C code, you are actually writing instructions for human, and that creates gap. Humans think in logic, machine works with execution steps. You think if the number is greater than 10, print it. The machine needs load the number, compare values, decide a path, execute instructions. This gap between thinking and execution is exactly what programming deals with. And now we are ready to see how this gap is filled. Think about how you use GPS navigation. You don't tell the GPS how to calculate routes, how to read satellites, how to draw the map. You simply tell it, take me to the nearest hospital. The system internally understands your request, break it into steps, execute those steps in correct order. You provide logic, the system handles the execution. Programming works the same way. In C programming, the system that performs this translation is called a compiler. A compiler reads your entire C program, converts your logic into machine instructions, produces an executable file. This translation happens only once. And this is a very important point. You don't run a .c file, you run the executable created from it. Once you understand this, many doubts automatically disappear. Now, why does C use a compiler? Because C is designed for speed, control, low level access. C gives you power, but it also expects responsibility. And that's why C doesn't hide execution details. It expects you to understand them. And that's exactly what you're doing here. Now let's slow down and clearly understand what happens from the moment you write code to the moment the program runs. Stage 1, preprocessing. Before actual compilation begins, the preprocessor runs. It handles things like hash include, hash define. The preprocessor copies the content or include the header files into your program. No checking, no logic, just text replacement. Stage 2, compilation. After pre-processing, the compiler checks your code. It verifies syntax rules, data types, structure of the program. This is where compile time errors occur. If something is wrong here, the program stops immediately. No executable is created. Stage 3, linking. Now the linker comes into play. It connects your code and the library functions. For example, when you use printf function, the linker connects your program to its actual implementation. If linking fails, the program cannot run. Stage 4, executable creation. Once everything is correct, machine code is generated and executable file is created. This file is independent, ready to run, pure machine instructions. Now that the executable exists, execution can begin. And here is a rule you must remember forever. Execution always starts from main function, not from header files, not from global variables, always from main function. Inside a function, instructions are executed top to bottom, one step at a time. No skipping, no guessing. Machines strictly follow order. That's why logic and order are so important in programming. Now let's talk about errors. First, compile time errors. These occur before execution. For example, missing semicolon, undeclared variables, syntax mistakes. The program never runs here. Second, runtime errors. The program compiles, execution starts, then the program crashes. For example, division by 0 and invalid memory access. Third, logical errors. The program compiles successfully, runs successfully, but produces wrong output. No error messages, no warnings. This is where real programming skill is tested. Syntax errors stop your program, runtime errors crash your program, logical errors fool your program. Good programmers learn to catch logical errors by understanding execution. If this explanation helped you see more clearly, take a second to like the video. It helps this reach someone who needs clarity. Subscribe to Scroll to Code and press bell icon so that you don't miss the fundamentals that actually matters. If you know someone struggling with C, please share this video with them. And if you have a doubt or something did not click, comment below. Many future videos are built from your questions. In the next video, we'll break down the structure of a C program line by line. Until then, keep your logic sharp. This is Scroll to Code signing off.